Hello students, today we will be seeing sets theory part. First, a disclaimer. The images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the same. Thank you. So, first of all, let us understand the course structure of class 11th mathematics. Simply, mainly you will see this unit sets and function will be covering 23 marks out of 80. Your theory paper will be of 80 marks and other 20 marks will be given in internal assessments. Second unit consists algebra only, 25 marks in algebra. You will be seeing limits, continuity. Coordinate geometry will consist your 12 marks. Calculus consists your 8 marks. And stats and probability combined consists your 12 marks overall. And you will have 80 marks of your theory paper. And other 20 marks will be given in internal assessments, tests, etc. Okay, mainly this is the structure of class 11th. Now, what we will be seeing in today's session, let's see one by one. So, we will be covering collection. What do we mean by collection? Then, what this specific term, we will be seeing its definition, what its meaning, well defined, very important in the context of set. Then we'll see examples of sets. Then not well defined, we will be seeing these also, that what do we mean by not well defined through examples. Then set definition, formal set definition. Then elements, what do we mean by elements of a set. Then representation of a set. So what are the different forms in which we are going to represent our sets. You will be seeing roster form. You will be seeing in roster form listing elements. And then set builder form. And finally, we will be seeing some examples in order to understand the theory well. So starting with some introduction. So the concept of set serves as a fundamental part of present day mathematics. As you open any chapter, you will knowingly or unknowingly, you will be encountering with sets. Sets are used in almost every branch of mathematics. So main are relations and functions. In relation and function, you always define your relation and function from a set to another set. Also in geometry, sequence and probability. In probability, you talk about your events. Yeah. So for now, we will be only focusing on sets only. Okay. So starting with collection. So what is collection? So we will examine the following things, collections. First, odd natural numbers less than 10. If someone says odd natural number, give me odd natural numbers less than 10, you can easily say 1, 3, 5, 7, 9 are some natural numbers which are less than 10 and they are odd. Okay, so far so good. Now what about the rivers of India? You can easily name them or you can Google it. If someone says give me vowels in English alphabet, you can easily name it. Name them as A, E, I, O, U. These are the 5 vowels. Very simple. And also, if someone says what are the various kinds of triangles, name it. Right angle, isosceles, scalene, etc. You can easily name them. And if someone says prime factors of 210. Just 2, 3, 5 and 7 are the some prime factors. And if someone says you are having an quadratic equation x square minus 5x plus 6 is equals to 0, the solution set will be given by simply 2 and 3. So here we saw some collections. Yes, in first collection of odd natural number less than 10 and so on. So you can easily, if someone said something or says that some definition in which you can easily answer it without any ambiguity, without any vagueness, then that will be your collection. Collection is just collection. Clear? So you will be encountering with a term which is very important, which is well defined. So first is collection. I hope the collection is clear. So collection is just elements you are having based on someone's question. Now well defined, the very important word. So we note that each of the above example is well defined. Only well defined things you can answer. Collection of objects in the sense that we can define or decide whether a given particular thing object belongs to the given collection or not. Simple. If you are able to make your decision that or decide that a given particular object belongs to the given collection or not, then it is well defined. Otherwise it is not. Example, say suppose someone saying set of natural number. Yeah, you can easily define it. This is very well defined thing. Set of all integers, well defined thing. Set of all rational numbers denoted by Q. Set of all reals denoted by this R. Z plus denotes the set of positive integers. You know, set of positive integers just consisting 1, 2, 3, or you can say the natural numbers. Q positive means Q represents your rational number. Positive gives you set of positive rational number. R plus gives you positive real number. I hope this is clear. These are well defined sets in mathematics. N represents your natural number and so. Now, formal definition of sets. So this formal definition consists of two very important words, which is well defined and collection. So a set is simply well defined collection of objects. Simple definition. Objects, elements and members are some synonyms we use in context of sets. Sets are usually denoted by capital letters A, B, C, X, Y, Z and so on. The elements, the members are denoted by small ABCs. Okay, A, B, C, X, Y, Z, etc. If A is an element of set A, we write A belongs to A. So this is your belongs symbol. If B not an element of A, then we write B does not belongs to A. So this is the symbol for does not belongs to. Clear? Now, so representation of sets. How we are going to represent our sets? So mainly there are two methods. First one is roster form. So let's see this form. So in roster form, all the elements of the given set are listed, and the elements are enclosed in between these curly braces and separated by commas. Simple. For example, if someone says set of all even positive numbers which are integer and also less than 7. So you can easily say that they are 2, 4 and 6. So in roster form, we are going to enclose them by curly braces and separate them by comma in this form. So this is our roster form. Clear? Now another example. set of all natural numbers divided which divide 42. So 1 divides 42, 2 divides 3, 6, 7, 14, 21 and 42. These are the all numbers which divides this number 42. And in roster form, we write them in this format, enclosed in between curly braces separated by commas. Set of all vowels in English alphabet, simply 5 vowels, A, E, I, O, U. In roster form, we write in this form. Now, a note, very important note, that writing the set in roster form, your element is not generally repeated. That is, all the elements are taken as distinct. We do not write all elements again and again. We just write an element only one time. For example, what we are referring is simply, if you are having your this word school and someone says that form a set of the letters from this word, so you are going to form SCHOL. You are not going to write O 2 times. It doesn't matter. Or the order also doesn't matter in sets. You can also write HOLCS. So order and repetition doesn't matter here. Clear? Now, another form is set builder form. So what we just saw was roster form. Now we are seeing set builder form. What do we mean? Is very simple. All the elements of a set possesses a single common property which is not possessed by any element outside the set. Simple. If it is not clear by this definition, it will be clear after seeing some examples. So here, so this is our roster form set AEIOU. Now how you are going to form this in set builder? Very simple. Each of the element is a vowel in English alphabet. No other letter possess this property. So you are going to denote your set builder form set by V and write it as all X such that, so this represents your such that, so collection of X such that X is a vowel in English alphabet. So in set builder form, so your set builder form must be in between these curly braces, and in that you will have two parts. One is collection of your X, your elements, and separated by these such that, we read it as such that, and here we write the property. The property we are talking about, that our elements, our members should be satisfying this specific property. In this case, X is a vowel in English alphabet. So after seeing more example, it will be clear if it is not clear up till this point. Now, for example, solution set. Now we have to form solution set of this given quadratic equation in roster form. So solution, simple equation can be rewritten as, in this factor form, x minus 1 times x plus 2, and here we can easily say that there are two values for which the equation is going to be satisfied, so 1 and minus 2. Now therefore the solution set of the given equation can be written as enclosed in between curly braces separated by comma, so 1 and minus 2. Clear? Write the set. So simple, this set builder form is given to us. So how we are going to read it? Very simple. Collection of all X such that, this says such that, satisfying this condition. Condition is X is a positive integer. First of all, X will be your positive integer, and X square must be strictly less than 40. So come up with positive integers and square of it must be less than 40. And enclose them in your curly braces separated by comma. Simple. So solution. So numbers. So square is 1, 4, 9, 16, 25 and 36. So these all numbers satisfying this condition as well as the positive integer condition. So now we are just going to enclose them in between curly braces and separated them by commas. And this will be our roster form. Clear? Now, let's see if your roster form is given to you, say capital A, your set is elements are 1, 4, 9 and so on. And we have to find out some common property possessed by all elements by which we can make this roster form in set builder form. So solution. Very simple. Just try to observe what is happening here. So 1 is simply 1, 2 is 2 square is 4, 3 square is 9, 16 is your what? 4 square, 5 square is 25, and now you can follow the pattern is going to same. So what is happening? Very simple. So collection of all x such that x is your square of a natural number. So simply natural numbers are 1, 2, 3, 4. If you square them, you will get this set. So 1 square, 2 square, 3 square, 4 square and so on. Alternatively, we can write our set builder form in this also. So collection of all x such that x is equals to n square, where n is from set of naturals. I hope this is clear how we are writing our set builder form. So in set builder form, you have to just analyze the common property shared by all elements. This will come to you after some examples. Just practice. This question, roster form given to you, find its set builder form. Solution, just analyze some kind of property. So we see that each number in given set has numerator 1 less than the denominator. So 1, 1 here, 2. So 1, 2. Now if 2, then 3, 3, then 4 and so on. Also the numerator begin from 1 and do not exceed 6. Hence in set builder form, we are going to give these two properties. So very simple. Collection of all x such that x will be of the form x is equals to n by n plus 1. As you can see, if this is your n, then this will be your n plus 1. Okay. Then n must be your natural number. Clear? Also, n is less than equals to 6 and it can be minimum to minimum 1. So n must be greater than equals to 1. So satisfying all these three, you will have your roster form this, and from this roster form you can build your set builder form like this. I hope it is clear. Now example, so you'll have table in which you have to match the corresponding elements to the correctly described set builder form. So at left you are given with roster form, at right you are given with set builder form. So match the correct. Simple. Now let's see the solution. Very simple. That this table is given to you. So solution. If you observe this first, so you are given with these letters PRINCAL and observe your right hand column, you will be seeing these letters are from the word principal, meaning you can match first to D. Why? If this is your roster form, then the set builder form will be collection of all X such that X is a letter of the word principal. So letter of all the words from all the letters from the word principal are P-R-I-N-C-A-L. As we saw in theory, there will be no relevance of the order. You write P here or here, doesn't matter, and the repetition also doesn't matter here. Clear? Now, so D matches with I or I matches with D. Also, for this singleton set 0, you will be seeing what do we mean by singleton set. So for now, this is your roster form in which you are having only single element, 0. Now just observe what set builder form gives you, just 0. So very simple. So here, if you observe this, collection of all X such that X is your integer. First of all, X must be your integer and satisfying the condition. So just solve this equation, you will get X is 0. So the solution for this equation is X0 and 0 is your integer. So the roster form for this will be just 0. The reason, so this is the reason why we are matching first to C. Clear? Now for next parts, table given to you. We left with third and fourth solution. So in such question, always start with your set builder form. Try to convert it in roster form, then match them. Very simple. So here, so A says collection of all X such that X is your positive integer. So X is your positive integer and a divisor of 18. So positive integer and divisor of 18. So first of all, list all the divisors of 18. So you will get 1, 2, 3, 6, 9, 18. And positive divisors 1, 2, 3, 6, 9, 18. And these elements are given in third option. So match 3 to A. Simple. Now match remaining to remaining. Very simple. So or you can try to change this set builder into roster form. You will get the same answer as this. So X must be your integer and solution of this quadratic equation. So solution for this quadratic equations, very simple, plus minus 3. So your set builder form, for set builder form, this set builder form, the roster form will be 3 comma minus 3 enclosed in between curly braces. Clear? I hope this is clear. Now let's see some more questions. So we have to write the following given sets in roster form. So A set builder form is given to you. Collection of all X such that X must be real and satisfying the given linear equation. Second, B, collection of all X. This is also your another notation for such that. So X such that X satisfying the property X square is equals to X and X belongs to real number. And third, C is your set collection of all X such that X is your positive factor of a prime number P. I hope these set builder forms are clear to you. Moving to solution. So first, A is your set builder form collection of all X such that X belongs to reals and satisfying the linear equation 2x plus 11 is equals to 15. So for this solution is, so very simple, just first of all solve this equation and trying to see that what are the solution elements and align with this condition that they must be reals. So solving it, we are getting simple x2. Simple. So you are getting x as 2. So A set is simply your singleton set in which you are having your single element. So 2. Clear? There, comma. Clear? Moving on to next part. So for B part, B is given to us x such that x square is equals to x belongs to set of reals. Solution. So already given to us this set builder form. Solving this quadratic equation, x square is equals to x square minus x is 0. Factor form is x times x minus 1 is equals to 0. So we are getting two solution, so two values for which the quadratic equation going to be satisfied 0 and 1. So roster form will be 0, 1. Simple. I hope clear. Moving on to next part. Part C. So set builder form is collection of all x. X must be positive factor of a prime number p. So p is your prime number. Solution. Set builder form, x is your positive factor of a prime number p. So first of all, you must know about prime number. So prime number greater than 1 whose only factors are 1 and itself. Such numbers are your prime numbers. Hence, so factors for any prime number p is simply 1 and the number itself p. So roster form is 1, p. Clear? Moving on to next. This question. So write the following given sets in the roster form. So D, this set builder form is given to us. Collection of all t such that t cube is t belongs to reals. E set is collection of w such that w minus 2 divided by w plus 2 is w plus 3 is equals to 3, where w belongs to set of reals. And set F, set builder form is collection of all x such that x raised to power 4 minus 5 times x square plus 6 is equals to 0, where x belongs to reals. So set builder forms are given to you, and try to find out the roster form. Simple task. So let's see the solution one by one. So starting with this first part D. Collection of all t such that t cube is equals to t belongs to reals. Solution. Set builder form given to us. So starting with solving this cubic equation, t cube is t. Transferring this right hand side t to the left hand side, we are getting the factor form as t times t square minus 1, and this can be rewritten as t minus 1 times t plus 1. And now we are having our equation as t times t minus 1 times t plus 1 is equals to 0. From here we can easily say that there are three values for t for which the cubic equation going to be satisfied. So minus 1, 0, 1. Therefore, the roster form is minus 1, 0, 1. List of all elements separated by commas and closed within the braces. Clear? Moving on to next part. So for set E, set builder form is collection of all w such that w minus 2 by w plus 3 is equals to 3. W belongs to all reals. Solution. So roster form we have to find out for this set builder form. Starting with solving the given equation, w minus 2 by w plus 3 is equals to 3 by 1. So w minus 2 is equals to 3 times w plus 3. We are getting w minus 2 is equals to 3w plus 9. So 3w minus w minus is equals to minus 2 minus 9. So 3w is minus 11. Sorry, 2w is equals to minus 11, which gives me w is equals to minus 11 by 2. So the only solution for the given equation is minus 11 by 2, which belongs to the set of reals. Therefore, this roster form is simply a singleton set, which is a set containing only single element minus 11 by 2. Clear? Moving on to next part. So third part, set builder form f x such that x raised power 4 minus 5x square plus 6x is equals to 0, where x belongs to set of reals. Solution. So just find out the roster form of the given set builder form, starting with this equation. So this is your biquadratic. You will see why we are saying it is your biquadratic equation. Just substitute x square is equals to t, and now you are having your quadratic. So if such is the case, then you will say your equation is your biquadratic equation simply. So you can easily solve this quadratic equation. T square minus 5t plus 6 is equals to 0. So middle term splitting, we are getting t square minus 2t minus 3t plus 6 is equals to 0. So t minus 2 times t minus 3 is equals to 0. From here we can say that 2 and 3 are the only two values for which this quadratic equation going to be satisfied, and t is just nothing but x square. So for t2, meaning x square is 2, so we are having x is equals to plus minus 2 plus minus root 2, two values. And for t3, we are getting x square 3, so x value is plus minus root 3. So in total we are getting 4 values for x, and these 4 values belongs to the set of reals. So roster form for f is going to be simply collection of all elements satisfying this biquadratic equation. So elements are minus root 2 plus root 2 minus root 3 plus root 3. Clear? The roster form is simply given by these. I hope this is clear. Moving on to next. This question. So in the following statements, you have to find out which are true and false, and then justify your answer. So first, 35 belongs to this set or not. You have to find out, is it true? So 35 belongs to collection of all x such that x has exactly 4 positive factors. 128 belongs to this collection of all y such that the sum of all the positive factors of y is 2y. 3 does not belongs to the collection, and collection is collection of all x such that x raised power 4 minus 5x cube plus 2x square minus 112x plus 6 is equals to 0. 496 does not belongs to the collection. Collection is y, collection of all y such that the sum of all the positive factors of y is 2y. I hope the question is clear to you. We have to just figure out the statements are true or not and justify if it is true and if it is false. Simple. So starting with the first part. First part says 35 belongs to the collection, and collection is collection of all x's that x has exactly 4 positive factors. Solution. So just first of all figure out this roster form for this set builder form, and let's figure out for this number 35. So factors for 35, positive factors for 35 are 1, 5, 7 and 35 itself. If you try to see 35 having exactly 4 positive factors, meaning this element must be element or belongs to the given set. So first statement is true. I hope this is clear. Moving on to next part, second. So 128, so statement second says 128 belongs to the collection. Collection is y such that the sum of all positive factors of y is 2y. So solution. Starting with analyzing this number, is this satisfying the condition? If it belongs to the set, then it must satisfy the condition. So first of all, list out all the factors, positive factors of 128. So 1, 2, 4, 8, 16, 32, 64, 128. Now, sum of all the positive factors of y. So add them. So adding, what we are getting is 255, which is not equals to 2 times of 128. So not satisfying the condition, meaning second statement is false. Clear? Moving on to third. Now in third statement, we are having 3 does not belongs to the collection. Collection is collection of all x as that x raised to power 4 minus 5x cube plus 2x square minus 112x plus 6 is equals to 0. Simple. Solution. So first of all, we'll just put 3 in place of x in this equation and try to see the equation is satisfying or not. So equation x raised to power 4 minus 5x cube plus 2x square minus 112x plus 6 is equals to 0. For x3, 81 minus 135 plus 18 minus 336 plus 6 is equals to 0. So we are getting left hand side as minus 346, which is not equals to 0. So in general, minus 346 is equals to 0. Is it true or not? Not. It is not true. So not true. Meaning 3 not belongs to the set. Meaning third statement is. So third statement is true. Moving on to next. Now fourth part. So 496 does not belongs to the collection. Collection is y. Collection of all y such that sum of positive factors of y is twice of y. So solution. Starting with the condition. So first of all, listing all the factors of 496. We are getting 1, 2, 4, 8, 16, 31, 62, 124, 248, 496. Add them. The addition is 992, which is indeed twice of this number 496. Meaning this number 496 satisfying the condition. So it must belongs to the set. Whereas this shows it does not. So 496 must belongs to the set. Hence, fourth statement is false. I hope the solution is clear to you. So for this part, this is it. Thank you for this session.